What's up, everybody? Welcome back to another episode of the BlockHash podcast. Today, I have another exciting guest here from Blocksense, co-founder and CEO Zahary, to discuss what Blocksense is, being a roll-up of verifiable data in compute services, and being built so that everyone can securely access any data on-chain. Zahary, welcome to the show, man. It's a pleasure to have you on today. How you doing?
Thank you for having me, guys.
To get started, would love for you to share a little bit about your personal journey into the world of Web3, and a bit about what sparked your interest and how you ultimately became involved with Blocksense.
I guess my journey is a bit unusual to the crypto space. Basically, I started in crypto because I had this unusual hobby of being a compiler engineer for the NIM programming language. I did this for many years, and basically one day, the founder of a company called Status showed up in the NIM community, and he announced that Status is interested in creating an Ethereum client in NIM. And basically, I didn't know that much about Ethereum back then, but for me, this was an opportunity to kind of prove to the world that the language I have helped created is actually worthy for this task. It was probably one of the first major projects in NIM. There was not so many companies using the language back then. So I became the first engineer. I helped them recruit many other kind of highly prominent members of the NIM community. And we created something like a dream team, I would say. Um, Pretty much everybody didn't have the blockchain experience or background, but we kind of quickly closed the gap in our knowledge, and we were able to develop on par with the other Ethereum development teams. Back then, the goal was we were calling kind of the project Ethereum 2.0. It was basically the transition from proof of work from proof of stake. Nimbus participated in the development from the beginning, and we were kind of one of the clients which were ready for the merge when it happened.
Awesome. And then, Zahary, what inspired you to create Blocksense? What were the problems that you were trying to solve, and how does Blocksense address them?
Well, Blocksense is trying to address one of the most fundamental problems in blockchain, which is how do you get data from the real world on chain in a kind of verified way, so in a way that nobody can manipulate the truthfulness, the veracity of the data. This is a problem because it's not that hard to get data on chain. But the issue is that once this data controls potentially billions of funds, how do you make sure that nobody can tweak the signal, basically decide what to upload in the right moment so they can walk away with a lot of the funds under control. And kind of we're solving this with a novel decentralized protocol that has some unique security properties that we believe make our protocol stand out from the rest of the ecosystem. But more importantly, we're trying to address another kind of fundamental issue in the way that the ecosystem is organized right now. Basically, in the current landscape, there are few big companies which are deciding what data should be uploaded on chain. Like these are the big Oracle players of today. And only once the data is available on chain, only then can entrepreneurs or builders start to thinking about how to take advantage of this data, what kind of applications they can come up with, and so on and so forth. We're trying to turn this problem around. Basically, if you are an entrepreneur and you have some idea how to leverage data from the real world, with our system, you can implement the Oracle that you need by yourself. We have an SDK that allows you to basically program how the data should be brought on chain. You can obtain it from potentially multiple internet data sources. You can do arbitrary computations on the data before it reaches the chain. And once you've created this program, you're basically asking our network to execute this program for you in a trusted and verified way. And this makes sure to your users that your protocol remains well designed and that you don't have the capacity to rug pull them or pull out any other.
Can you break down the technical aspects a little bit further of the Blocksense protocol? Like, how does it work, and what are some of the core components that really make it unique and stand out?
Sure. Basically, it's a protocol that tries to combine game theoretical approaches with advanced modern cryptography. The basic idea is very simple. It works like a game. Imagine a game with, say, 10,000 participants, where you secretly select a small subset of them, say 100, and you ask them an arbitrary question. For example, what's the current temperature in New York? And the rules of the game are such that if you provide an answer that agrees with the majority of other answers, you get a reward in this game. But if your answer disagrees with the majority, you get a penalty. And it's not immediately obvious, but the kind of winning strategy here is to always tell the truth. Because if everybody tells the truth, everybody is going to win. And if you try to lie, since there are so many possible ways of lying, it's quite unlikely that you end up in a majority. So basically, these games incentivize the reporting of truthful data. But since it's a decentralized protocol, and maybe the voters are doesn't have to pay, they can be anonymous. You have to be worried about possible collusions between them, or maybe kind of somebody stepping in and trying to bribe the participants in the protocol to steer the result in one direction or another. And here are kind of key innovations come in. The first thing that we do is we make these voting committees secret. Basically, a voting committee is this the small subset of participants deciding on a particular topic or question. So when you are in one of these committees, you know that you are a member, but you don't know any of the other members. And if you're an external observer, you don't know at all who the members of the committee are. So basically, if you want to collude with somebody or if you want to bribe somebody, the first problem is that you just don't know who to target. And then the second kind of problem that we introduced for the attacker is that we make it very difficult for anybody to review how they vote within the system. Basically, the only way to review your vote is to also disclose a secret key that you have in the system, which controls your entire stake. And naturally, nobody would want to do that. But then think about it. Would you really try to bribe somebody if they cannot prove to you how they vote? Because they can always take the money, vote whatever way they want, and you would have no mechanism to verify whether they have followed your orders or not. So we believe that these added layers of security make this protocol uh, properly secure for the very first time. It's otherwise an old idea. Vitalik introduced it more than 10 years ago. Uh, but this is one of the reasons it hasn't been deployed at scale. The other reason is that um, if you execute this voting process on chain, you have to pay a lot of gas for all the actions of the participants. But what we do is we take it off chain. All the voting is executed in a peer to peer network, and we can kind of come to consensus to thousands of the individual votes. Basically, the consensus um, algorithm in our network is implemented as a zero knowledge circuit. So we can execute this circuit over thousands of different questions in this game, and then we can aggregate all of the results together and publish them with a single transaction on chain, verified with a single recursive zero knowledge proof. And the fact that we publish thousands of data points together is really what kind of puts Blocksense in a separate category, because most of the other Oracle networks have this design where every data feed is a separate smart contract and every update is a separate transaction. And while, for example, if you try to populate an Ethereum block entirely with updates from kind of the leading Oracle providers of today, you'll be able to fit only around 100 updates or so. While in our system, which is designed as a kind of ZK rollup, a single transaction can carry thousands of updates. So that makes a huge difference in terms of the cost of publishing data online, how much data you can get online, and having this increased bandwidth, you can actually also use it to increase the frequency of your updates. Basically, for the same gas cost, you can update more data more frequently. And this solves one of the key problems with Oracle today, which is that the data is often stale. It's not updated frequently enough. And finally, all of this is possible today, mostly for another reason. Basically, it was difficult to bootstrap such decentralized protocols in the past, because until you have significant crypto economic security behind the system, it's difficult to find your first users because the system will be easy to manipulate. But right now, with the emergence with Eigenlayer and other risk-taking protocols, uh, we are able to very quickly bootstrap the crypto economic security of the system to a very sufficient levels.
Very nice. I really like the security aspects as well. I think that's very interesting and unique to what you guys are doing. You've mentioned that anyone will be able to essentially create a new oracle through the protocol. Could you also elaborate on this process and what steps are involved and maybe what some of the requirements are for creating a custom oracle?
Right. So our current SDK is basically based on WebAssembly. This means that you can use any programming language that compiles to WebAssembly to create these Oracle scripts, as we call them. But Oracle scripts even is a bit of a misnomer because kind of the you can do arbitrary things with the SDK. For example, you can take the contents of some web page, you can run these contents through the latest and greatest large language model, asking it a question about the content. It can come up with an answer, and this answer could be kind of what you upload on chain. For example, this would be an interesting way to resolve prediction markets, for example. But what I'm trying to highlight here is that the programmability of this SDK is very, very, very general, basically because our voting mechanism, the voting mechanism I described earlier, it can really be applied over arbitrary questions or arbitrary programs that are executed in this case. So with this SDK, we envision that people will be creating various bridges, indexers, all kind of other blockchain infrastructure as well, and not just only oracles.
I saw an interesting article actually in your company blog about another very interesting use case regarding Blocksense, a versatile compute network. Can you tell me a bit more about that?
Yeah, that's a bit more, indeed, very surprising outcome in our own thinking. Um, the reason Blocksense can become an interesting compute network is the fact that when you are operator in Blocksense, and anybody can become an operator, if you think about kind of what you are aiming to achieve as an operator, is that you are giving us your hardware, you are entrusting us with your hardware, and you're basically asking us, okay, what can the Blocksense protocol do for me so I can earn as much money from the hardware that I have entrusted you? And if you think about where is your revenue coming from? So in traditional compute networks, you're saying your computational capacity, your kind of networking bandwidth, and so on and so forth. So other people can run their workloads, and kind of you charge them money for that. But in Blocksense, something different is happening. You're not being paid for kind of the few milliseconds that you needed to execute one of these Oracle scripts, or the few kilobytes that you have to send to the chain to kind of report your results. The value that is being created is something else. It is the kind of veracity, the guarantee that the data that is being uploaded on chain is authentic and verified. And the value of this is something that is much greater than the computation itself. Like, because this value can protect potentially billions of dollars, basically the stakeholders in this system that has billions of dollars inside it should be willing to reward the reporters significantly more than the mere cost of their computations. Right? I hope this argument makes sense. So this would mean that initially, most of the operators in Blocksense will be earning kind of high profit margins because they can buy a single machine and they will be assigned many of these reporting tasks that earn them kind of high profit margins. But people should notice this over time, and we will have more and more reporters willing to join the system. That's what the market dynamics should determine. And at some point, it's likely that this kind of system will get saturated with reporters. There will be more people than reporting jobs for them. So a lot of the reporters will be just sitting idle. But if we kind of get back to the original goal, our goal was to just make as much money as possible for the reporter. So this means that this idle time is a little bit something like a kind of wasted resources. We can use it to uh, run other more traditional computational tasks on the network that still earn some revenue for the operators. And kind of we cannot expect that the rewards in this more traditional tasks will be different from the traditional compute environment. And the traditional compute environment is dominated by this kind of the big tech, the hyperscalers of the world, Google, Amazon, and so on and so forth. So they have huge economies of scale, and naturally they put a ceiling on just how much money anybody can make by competing with them. So the pure compute market will always be kind of low margin activity, low profit margin activity. But if you look what happened in kind of is the setup that I described, which is basically for a bit of the time, maybe 10% of your time, you are running these high profit margin activities. And say for 90% of your time, you're running traditional compute with low profit margins. The aggregate, the total of both, would still be higher than somebody who is running 100% low profit margin tasks. I hope this also makes sense. So this means that Blocksense should become kind of highly attractive network for operators, basically people who are giving away their hardware in the hope of making as much money as possible. And once the network becomes popular with the operators, we can achieve something like a global reach. Basically, we can maybe have operators in every single city in the world, and things like that. And then we believe that in the future there are some interesting use cases coming up, which are, for example, latency sensitive applications. You can think of it, for example, in the AI space. I think there's a lot of this coming. Once we start kind of having conversations with AI agents and allow them to, say, process video streams in real time, and we can point our phone around to our surroundings and ask the AI to label things for us, kind of things like that, or give us instructions. Uh, if you have an AI agent that is near you in the same city, for example, this would it would be much more responsive user experience than if your agent is running in a data center that is kind of millions, hundreds, sorry, thousands of kilometers away from you, right? So that's one use case. Like there are other interesting established use cases for low latency in gaming and so on and so forth. The properties, kind of typical hardware requirements for the operators in the Blocksense network make it are very well suitable for these use cases. Because in the Blocksense network we also have operators which can take advantage of modern trusted execution environments, security enclaves, and so on and so forth, which are the ideal way to kind of implement these modern AI products without sacrificing the privacy of the user, for example.
Very nice, man. And is Blocksense currently accessible to the public right now? Or if not, what's the timeline actually for wider adoption and integration?
We've recently launched what we called our MVP on a number of testnets. This is a product that can act as a drop-in replacement for the chaining smart contracts. The problem we're trying to solve is that if you are a new chain, for example, the only way to be successful is to be relevant with end users. And the end users, what they desire is to have a very rich variety of applications deployed on your chain, kind of all the typical DEXs, lending protocols, perpetual product markets, and so on and so forth, as well as various DApps that are relevant for them. And it happens so that many of these existing applications, they depend on chaining. They have it as a prerequisite before being able to be deployed somewhere. And this forces the new chains to kind of work with these existing Oracle group providers, but kind of the process of getting them deployed is time consuming. It could be very expensive, and so on and so forth. So what we are offering instead is a system that allows pretty much everybody to deploy our smart contracts permissionlessly. They can act as a drop-in replacement for these existing Oracle providers, which means that all the existing dApps and protocols can be deployed with Blocksense without any modifications out of the box. And in the long term, block science is really designed to act as the most efficient marketplace possible, where the consumers of the data are on one side and the reporters that I described previously are sit on the other. And because there's an element of competition between the reporters, they're bidding against each other for the cost of providing the Oracle services. We should expect that over time, this market will always be finding the optimal price point for these services. And the mechanics of the system are such that if more chains are adopting Blocksense, over time they're sharing the cost, basically sharing the burden. So over time, the cost will get lower and lower for everybody, to the point where kind of no competing Oracle provider will be able to offer something similar if they don't have a volume, our large volume.
Which protocols or projects do you anticipate being the first to really integrate BlockSense? And then what synergies do you foresee with those partnerships?
One category of project that we are after are new chains, which are going to market. They still haven't decided on our Oracle provider. But another category of project that we are seeing is that basically teams that need something custom to be built for them. And the way this works is typically when we approach a development team, we tell them that we can serve their current data needs in a much more cost-effective way. But we always also ask them, do you guys need any additional data that is currently on chain, but that would make a difference for your product? And almost universally, everybody have some ideas how, if they bring some additional data on chain, their product would be improved for their end users. And they're very excited about kind of the prospect of using our SDK to get the data that they need on chain. So we have a number of these integrations where we're helping kind of projects with developing bridges between different blockchains, which are kind of monitoring very specific events, or kind of very custom price feeds, which are calculated with kind of custom methodologies, or sometimes kind of we can bring new price feeds for new emerging assets, say a new meme coin that's getting popular, and we can do these sort of things very quickly.
I love it. How can the community stay updated on BlockSense's progress? Are there any channels, forums where people can kind of engage with the team and contribute to the project?
The best way for this would be to kind of join our Discord server, for example, or to follow us on x.com. Our handle there is, or both of them are available on our website, which is blocksense.network. So we also have a newsletter that you can sign up on the website if that happens to be your thing.
What are the key milestones and goals for BlockSense, going into the next few months here to end the year, as well as in 2025? Can you share any exciting developments or partnerships that might be on the horizon?
Well, with Blocksense, even though we kind of, what I described earlier is the most ambitious goal of our system, protected with secret voting and the secret committee elections, this would be developed as a zero knowledge circuit, and it certainly takes us some time to kind of implement correctly and make sure go through security audits and everything necessary to run something like this. But we believe that uh, our SDK, basically this bringing permissionless Oracle creation to the current ecosystem, is something very important. So we really didn't want to make it a hostage for this kind of complicated zero knowledge protocol development. So we are going to market as soon as possible with the permissionless Oracle creation. And the way we are achieving this is that we will initially work as a traditional Oracle provider. Basically, most of the Oracle providers today, they're based on reputation alone and nothing else. So they have few reputable companies which are signing the data, and everybody is supposed to trust that these companies will never do something that is kind of hurtful for the community, because they are risking their reputation this way. So we're taking a similar approach. We have a number of reputable large Blocksense infrastructure companies, such as, for example, Blockdaemon, Lugonotes, and Cold Club, and others, who will be the initial operators in the Blocksense network. They will be signing all the results from the Oracle scripts created through the SDK. And we expect this kind of rollout to go live and suitable for production use cases before the end of this year. Now, the next milestone for us would be becoming an AVS in Eigenlayer. I mentioned this earlier. This would open up the system for large institutional operators, which have a lot of stake locked in for behind them in Eigenlayer. So at this point, the protocol will become slightly more decentralized, but still and based both on reputation and skin in the game, real skin in the game. But it still wouldn't be fully open for anybody to participate in the way that I described. And this would be our final, the next milestone, which is once our zero knowledge circuits are fully developed, we'll open uh, we launch our own token, and then anybody will be able to stake in the Blocksense network and become an operator permissionlessly. And this would be kind of the final phase of the Blocksense rollout. And the kind of further roadmap down the line will be based on more advanced features and functionalities of the protocol.
Excellent. Zahary, thank you for taking the time to come on the podcast today and really highlight what you guys are doing with Blocksense and Oracle creation. I think it's something that's very important in the space and obviously trending very quickly in the upward direction. We'll have all the links in the description below for anyone that's listening or watching the episode. Definitely go check out Blocksense. And Zahary, thank you again for taking the time, man. Really do appreciate it.
Thanks for having me. Bye-bye.